Students, today we will discuss about the nitro compounds. The nitro compounds are mainly RNO2, aliphatic nitro compound, and ARNO2, the aromatic nitro compound. R stand for the alkyl group and AR stand for the aryl group. Classification of alkyl nitro groups are further primary, secondary and tertiary. It will depend upon the attachment of this NO2 group with the carbon. If that is attached with the primary carbon, then it will be called as the primary nitro compound. If it is attached with the secondary carbon, then it will be called as the secondary nitro compound. And similarly, if it will be attached to the tertiary carbon, then the compound will be called as the tertiary nitro compound. Generally, the nitro compound isomerize with nitrite. The NO2, that is the point of attachment. If the carbon is attached with the N, then it will be simply a nitro group, and if the point of attachment of this particular NO2 group is with oxygen and carbon, then it will be called as the nitrite. Generally, these compounds are synthetically more important as comparison to alkyl nitrate, and they are quite stable. So we will discuss about the nitro compound, their nomenclature, method of synthesis, and their chemical properties. So first of all, we will discuss about the nomenclature of the nitro compound. And in case of nomenclature, generally the nomenclature is nitro word is used as a prefix followed by the alkane word for the aliphatic one. Alkane, ALK means the number of carbon atom in the chain, and ANE stand for the single bond. If it is double bond, then it will be EN, and if it is triple bond, then it will be YNE. For example, some examples are here. This is your nitro ethane. This is your in this case we will have to do the numbering. So numbering is starting from here 1, 2 and 3. So second position is now occupied by the nitro group. So the nomenclature will be 2-nitropropane. Now in this case we have two groups attached to the particular hydrocarbon chain, the NO2 group and hydroxyl group. So this hydroxyl group will be preferred over this NO2 group, so it will be used as a prefix, and this will used as a suffix. So numbering will start from, obviously it will start from the hydroxyl group. So 1 and 2, second position is occupied by the NO2 group, then it will be 2-nitro, and eth word is used for the hydrocarbon chain where two carbons are there. So 2-nitro, eth, and single bond AN, and OL is suffix for this alcoholic group. So 2-nitro ethanol. This is for aliphatic system. For aromatic system, they are generally named as the derivative of the benzene. For example, this one is a nitro simple, and this is your nitrobenzene. NO2 nitrobenzene is here, and this one is containing both the groups. Nitro group is also there, and CH3 group is also there. So this is 4-nitro-toluene. Similarly, this is your metadinitrobenzene, because it contains two NO2 group, and they are meta to one another. They are 1 or 3 relationship are there. So this is metadinitrobenzene. So this is a simple nomenclature of this nitro compound. Now we will come to the preparation. First of all, we will discuss the preparation of the aliphatic compound, then we will discuss the preparation of the aromatic compound. So first of all, nitroalkanes. Nitroalkanes can be prepared from the alkanes, and obviously if we have the simple nitration reaction, and in simple nitration reaction we generally use the fuming nitric acid at somewhat high temperature, and the temperature range is around 673 Kelvin, right? So in this, the NO2 group will replace one of the hydrogen, and the mechanism will be the free radical mechanism, and it will form CH3NO2. For example, this particular reaction we are doing, methane react with fuming nitric acid and will get converted into nitromethane, and water has been removed. There is a limitation of this reaction. The limitation is, first of all, the yield is very low. The second one, if the number of carbon atom in the hydrocarbon are more, then isomeric product will be synthesized. That means whatever we want to prepare, that will not only the product, some different kind of products will be synthesized, like carbon dioxide will be synthesized, water will be there, NO2 will be there, right? For example, this is your propane, and we are doing the nitration reaction on this particular propane. Now on this position, at primary carbon reaction will happen. Similarly, at secondary carbon the reaction will happen, and there will be fragmentation reaction as well, right? So we are getting nitropropane, we are getting nitroethane, we are getting 2-nitropropane, we are getting nitromethane. And along with these, we are also getting carbon dioxide, NO2 and water, etc. So this is the limitation of this kind of reaction, that we cannot prepare a specific product from this particular reaction, right? And the mechanism is free radical, so the order of reactivity will be tertiary, then secondary, and then primary. Now come to the second reaction, and the second reaction is alkyl halide. From alkyl halide we can easily prepare our nitro compounds, right? So for that reaction, generally we use alkyl halide that can be used for the reaction is alkyl iodide and alkyl bromide. Alkyl chloride and fluoride cannot be used for this reaction. We generally use bromide and iodide. It react with silver nitrite, AgONO. Silver nitrite has been used because this is a covalent compound, and in this compound this particular group, that is the nitrite group, is ambident nucleophile, and it has two sites of attack. Either oxygen lone pair of this O negative can attack, as well as the lone pair of nitrogen can also attack. So this is ambident nucleophile and it can attack on this R. The mechanism is simply a nucleophilic substitution mechanism, and during this mechanism, for example, I am particularly taking the example of this silver nitrite, which is a covalent compound. This nitrogen along with its electron pair will attack on this R, leaving this I negative, and AgI has been synthesized here and forming nitroalkane. Now this oxygen lone pair can also attack, but nitrogen will attack. It will depend upon the electronegativity. You, I think, know that is the negativity of this oxygen is more. So nitrogen lone pair of electrons are available to bond with this R instead of oxygen. So this will react with this one, and you cannot use you can only use silver nitrite. We cannot use other metal nitrites. For example, sodium nitrite we cannot use, because in that case the compound will be ionic in its nature, and because of ionic nature complete ionization will happen, and when complete ionization will happen, then the chances of nitrite formation will be more as comparison to nitro compound. So this is another method by which we can prepare nitroalkane. Now come to the third method. The third method is simply from alkyl amines, and generally we use tertiary alkyl amines, and that particular alkyl amine undergoes oxidation reaction by using the KMnO4, and it will be oxidized to nitro compound. So the limitation of this reaction is that it cannot be used for primary and secondary one. It can only be used for the tertiary alkyl amines. For example, this is your tert-butylamine, and this particular tert-butylamine on oxidation with KMnO4 will get converted into 2-methyl-2-nitropropane. The next reaction is oxidation of the oximes. Now you know that from where you have been synthesized this oximes. Oximes are aldoxime and the ketoxime. Both can be synthesized, and you studied this reaction, formation of oximes in aldehyde and ketones topic. When this react with hydroxylamine, means if this particular group, we can prepare this particular group by using RCOH. Aldehyde on reaction with hydroxylamine NH2OH, it will form this aldoxime, and aldoxime on further oxidation with trifluoroacetic acid will get converted into nitro compound, right? So this is another method by which we can prepare our nitroalkanes, oxidation of oximes, and that can be prepared from aldehyde and ketones. So this is a direct method of conversion of aldehyde and ketones into nitro compounds, right? Now come to the next method of synthesis, that is particularly from sodium chloroacetate. From sodium chloroacetate, this is your sodium chloroacetate, and this on reaction with sodium nitrite. Basically this is a nucleophilic substitution bimolecular reaction in which this NO2 group will particularly replace this chlorine, and here it is the attachment. Now this will followed by decarboxylation reaction. When this particular group undergoes heating at high temperature, it will undergo decarboxylation reaction, and on decarboxylation this will form this particular group, and which on hydrolysis with water molecule will get converted into your nitromethane. So another method by which you can prepare this particular compound is from sodium chloroacetate, right? And this can be prepared from sodium acetate or acetic acid. For example, when acetic acid react with chlorine, that can be also be this is chlorination reaction of the acetic acid. So first of all, the acetic acid can get converted into chloroacetic acid. On further reaction with sodium hydroxide, acid base reaction will happen, and that chloroacetic acid will get converted into sodium chloroacetate, which on further reaction with that one will produce your nitromethane. So ultimately you can convert that particular acid into nitromethane. For example, here you are having acetic acid, so acetic acid can get converted into nitromethane by using this sequence of the reaction. So here you are also learning the conversion, that how can you convert a particular compound into nitro groups. So this is all about the synthesis of nitroalkane. In tomorrow's lecture we will discuss about the synthesis of the nitroarenes.